Hi guys. So today we're going to continue solving equations, but today we're going to flip from looking at log equations to looking at exponential equations. Then the second day this week, there's really not going to be any new content. I'll have a short video that just kind of goes through maybe some tougher examples, but really this last day of this week is just going to be used to combine these two types of processes together. Because again, typically when it comes to solving these equations in the future, they're not going to be isolated as, okay, now here's your exponential equations and then here's your log equations. You'll just be given an equation and you need to know how to solve it. So we're separating them now to get used to the methods. But again, on Thursday, we're going to kind of combine these two together. So exponential equations have kind of two forms. The easiest way to solve an exponential equation, if it's possible, is to rewrite the bases in terms of the same number. Now, this won't always be possible. In these first two examples, it is. Because 3 and the square root of 3 can both be written as 3 with a certain base. So the square root of 3 is the same thing as 3 to the 1/2. Which means I can rewrite this as 3 to the 1/2 times x plus 1. Well, now that I have the same base, in order for these two things to be equivalent, the exponents have to be equivalent. So at this point, all I have to solve is x minus 1 equals 1/2 x plus 1. So x minus 1 is equal to 1/2 x plus 1/2. 1/2 x is equal to 3 over 2, and x is equal to 3. Very similar method on the second one. 1 over 9 and 27 can both be rewritten in terms of the same base. That base is 3. So 1 over 9 can be rewritten as 3 to the negative 2. 27 can be rewritten as 3 to the 3rd. And then since you have a power to a power, those exponents are multiplied. So negative 2 times 2x is going to be a negative 4x. This is going to be 3 to the 3x plus 3. At this point, if the bases are the same, all I have to do is solve to where the exponents are equivalent. So that's going to give me a negative 7x equals 3, and x is equal to negative 3 over 7. So if you are able to write these in terms of the same base, that is the easiest way to do it. Now, a lot of times, though, with exponential equations, that's not possible. You may only have one function that has a base, and you may not be able to write them in terms of the same base. So those are the examples we're about to look at. All right, so again, in this case, there's only one base and one number that actually has an exponent. Well, if that's the type of problem we have, what we want to do is isolate that expression. Okay, so I want to get 2 to the x by itself. So what I'm going to do is subtract 1 from both sides. Then at this point, I think I actually might have changed this example on your notes for this reason, but maybe not. Well, this one's pretty easy. This one's going to be 2. All right, but let's say this wasn't. Let's say this was the number I intended for the original problem to be. Let's say this was 15. Okay, then I would subtract 1. And at this point, it wouldn't be as easy to figure out what that variable is. So if that's the case and it ends up in that form, then what we need to do is rewrite this as a log. So this would be log base 2 of 14 is equal to x. Again, if it's something you can just figure out by knowing that exponent, great, do that. But something like this, we don't know 2 to the what power would give us 14, so then we would write it as a log. If it's non-calculator, you would leave it in this exact form. If it was calculator, then you could go ahead and evaluate it at this point. All right, let's go ahead and look at another one. So again, at this point, there's only one exponential or one part with an exponent, so we need to isolate that. So I'm going to go ahead and add 2, divide by 2. And then at this point, I need to rewrite this as a log. So then what I'm going to do is it would be log base e, but again, we don't write log base e. We would just write ln. So ln of 3 is equal to x over 3. Then at this point, to get x by itself, you would multiply both sides by 3. So I get that x equals 3 times the natural log of 3. Now there is another way that you can work this out, and this is a method we'll use here in these next couple problems. Instead of rewriting this as a log, we actually can take the log of both sides. You can take log or natural log. I'll go ahead and do natural log because it's a little bit easier since we have e. But what I could have done instead at this point is I could take the log of both sides. Well then, using my exponent properties, I can move that exponent to the front. And ln e is just 1. So this is just x over 3 equals ln 3, and you end up in the exact same place. So that's just a different method that you could use to work this out. All right, now that method's actually going to make these next two problems a little bit easier. Now you could write this as a log. You could write this as log base 2 of 3 to the x minus 1 equals x. You could move the exponent and you can solve it from there. I think it just gets a little bit more complicated that way though, with all the bases floating around, so I'm going to show it the other way instead. If you want to use that method, that's totally fine. One thing we do need to recognize about this question, it's not possible to write these in terms of the same base. Okay, 2 and 3, 2 to the something power and 3 to the something power, we don't know what those are. So this is a little bit harder than those first two questions. So again, what I'm going to do in this case is I'm going to take the log of both sides. So I'm going to do log of 2 to the x equals log of 3 to the x minus 1. Then based on our properties, that exponent can move to the front. And when I move x minus 1, I'm going to keep it in parentheses because that entire expression is moving. Now, we talked about how you can't distribute to an argument. Okay, that's an important distinction to understand. If this was log of 3 minus x, I can't distribute log to those arguments because the argument is part of the log. Now, in this case, though, we can distribute because this is the quantity of x times the quantity of log 3. Remember, log 3 is just a decimal. There is a decimal equivalent to that. So it is okay to go ahead and distribute here. To figure out your answer. Now at this point, this is going to be a pretty similar method that we used to when we were solving for inverses of rational functions. I'm trying to solve for x, so I'm going to get everything with an x on the same side. I'm going to factor out that x so that now I can divide by what's with it. Now at this point, guys, there are probably five or more different ways to write your answer. Okay, you can use your properties. You can rewrite this as the log of 2/3 if you want. You can rewrite this as the log of 1/3. You can use change of base formula and rewrite it at that point. But honestly, at this point, all we want is an exact expression for our answer. Once we have that, we can go ahead and stop. We don't need to simplify this in a bunch of different ways. But there are multiple different ways to represent this same answer. So even if your answer doesn't look the same, it could be equivalent. This is the point where if we had a calculator, we would go ahead and evaluate this part with a calculator. So our goal is to get x by itself with an exact answer on the other side. The format that you use is up to you. Now, if we use that other method, if I rewrote this as log base 2 of 3 to the x minus 1 equals x, my answer is going to look a little different, but it's going to be the same equivalent decimal. So if we went ahead and worked this out, okay, so just setting it up with that in that other format, that x minus 1 would move to the front. I can go ahead and distribute. I can go ahead and get all my x's on the same side. Factor out my x. And divide. So even though it's going to look different, if you plug these into a calculator, these two answers are going to be equivalent. So either of those is fine. That looks like a B, not an R. Either of those answers is fine. Variations of those answers is fine. Because again, they're going to give us an equivalent decimal whenever we work that out. Just a matter of whichever way you think is simpler. And to me, I just think that first one's a little bit easier. All right, so on this next one, pretty similar method. Again, either take the log of both sides or rewrite it as a log. I'm going to go ahead and take the log of both sides. Move the exponent to the front. I'm going to distribute, and I'm going to get everything with an x on the same side. So this would be x log 3 minus x log 7. This is going to be negative 2 log 3 minus log 7. Factor out that x. And divide by what's with it. And at that point, that's your exact answer. Now again, if you want to rewrite this, there's multiple different ways that you could format this, but this answer is exact. We've solved for x, we know what it is. At this point, if you had a calculator, you could plug this into a calculator to get that equivalent decimal, and then that's going to be the exact version of it. All right, so the last one, let me get that notification going. Sorry about that. First of the month. So what we're going to do on this one, this is a case where we need a factor. And this is a factoring question that for some of you guys, you may see how this factors. For other of you, you may need to use kind of that U substitution concept that we talked about. So this is kind of a factoring in disguise question. And what I mean by that U substitution, you don't have to use U. You can use any letter you want, but I typically don't use X because X is ultimately what we're solving for. So what I'm going to do is I'm going to let U take the place of e to the x. So if I did that, then this, instead of being e to the 2x, would become u squared minus u minus 6. And that, for a lot of people, is just easier to see how to factor than the original problem was. So this would factor into u minus 3 and u plus 2. So I would get that u equals 3 and u equals negative 2. Now the problem here, though, is I'm not really solving for u. I'm solving actually for x. So at this point, I need to go back and plug in what u actually stands for. So e to the x equals 3, e to the x equals negative 2. At this point, then, I'll solve these equations. Probably the easiest thing to do is rewrite it as a log. Well, e to the x equals 3 would be log base e of 3. But again, we don't write log base 3, we write ln. And we get our two possible answers. Now again, it's possible answers because, again, negative arguments are not going to happen. So I only have one answer here, and it's the natural log of 3. All right, so that's it for solving exponential equations. Again, what we're going to do is we'll spend some time today solving these, and then on Friday or Thursday, actually, it's really just going to be kind of a combo review of these two different methods combined together.